Hello everybody. Now we will see one more important topic called automotive E&E architecture. And what is this E&E architecture? Electrical and electronics architecture. So how are the various electrical and electronic architecture distributed or designed in a automobile? And this E&E architecture has slowly evolved and it has its own challenges. Now why am I talking about this E&E architecture? Because this has an extensive effect on ADAS. This E architecture, it has a considerable effect on advanced driver assistance system, and hence I am discussing this topic in elaborate. Now before I go to how it is affecting the ADAS, let me tell you how this automotive E architecture evolved and what are the various types of challenges as far as this E architecture is concerned. Because once you understand this, you will get to understand its effect on ADAS in a more clear, concise manner. Okay, here I go. Now, what are the main factors of driving factors of E architecture? The main driving factor is increasing in the number of ADAS, and increasing in number of ADAS is the first step to go towards L5 autonomous driving systems. So as the vehicle is progressing towards L5 autonomous system, the ADAS systems are more and more increasing, and this increment in the number of ADAS systems is the main driving factor, of the E architecture. What are the other factors? Heavy electrification and shift towards vehicle control unit model ECU, latest exhaust after treatment equipment, over the air updates for various ECUs. Well, I have allotted a complete chapter about the importance of over the air and how it is affecting the ADAS. Next comes the V2X communication, vehicle to everything communication. Next, it is also one more factor is exponential rise in cost. Okay, and I'll tell you how the initially cost was higher and how as E architecture is evolving, cost control is becoming an important factor or important advantage. Now increment in the weight due to length of the wiring harness, and increment in the complexity of wiring harness arrangement. Okay, so these are the main driving factors of the EE evolution. Now what are the challenges that need to be overcome? Now why did scientists or engineers first address this particular problem? What are the various challenges that are prevalent in the current situation? The most important challenge is too many ECUs. And why this is a problem? Vehicles have 70 to 100 plus ECUs. Now as the vehicles are progressing, as the vehicles are becoming more and more software defined, especially in the luxury vehicles like BMW 7 Series or Mercedes S Class, 70 to 100 ECUs are becoming a common number in the luxury ECUs. So making integration, this number is making the integration complex and costly. Now this is the biggest problem. Now next comes the limited software upgradability. Understand this word very carefully, limited software upgradability. And every ECU has a dedicated firmware, making over the air updates difficult. So over the air update on a given ECU is becoming difficult because every ECU has a dedicated firmware. Next comes the high wiring complexity. Over 3 to 4 kilometers of wiring increases weight, cost and maintenance issues, especially EMI and EMC. Electromagnetic interference and electromagnetic compatibility is becoming a big problem as 3 to 4 kilometers of wiring is increasing weight, cost and maintenance. Now when it comes to scalability issue, adding new features requires more ECUs, leading to exponential complexity. Okay, so and also slow data processing, and why is it a problem? Scan and LIN networks have bandwidth limitations of modern and ADAS infotainment systems. So modern ADAS and infotainment systems, they are eating up, so to speak, most of the bandwidth of CAN and LIN network. Again, when it comes to lack of standardization, different OEMs use proprietary software stacks and hindering interoperability. Even though there are some standards like AutoSAR and all, even today for confidentiality reasons, for competitive reasons, many OEMs are using their own proprietary software stacks. So this is badly hindering the interoperability. And coming to security vulnerabilities, more ECUs and networks increase attack surfaces for cyber security threats. Okay, so this is the important thing. As more and more ECUs are there, there are more and more scope of cyber security threat, because there are more and more openings of cyber security threat. It may be ECU itself or the ECU connecting route. So there are plenty, or the OTA. So there are plenty of ways this ECU can be attacked, and it can be a victim of cyber attack. Now, why is it big problem? Let me say, as per one OEM, one very famous OEM, the current E architecture with domain controllers and central gateway has grown over time and become very complex. Okay, it is a this wiring complex can go up to the weight of 80 kgs, and it can go up to the length of 5 kilometers. And also, this is a very costly component with a high cost of labor. So the cost of labor of arranging the entire wiring harness can go up to 1000 plus production minutes. This is one of the reasons why this particular problem had to be addressed, or it had to be collided head on. Now today's trends such as automated driving increase significantly the demand for wiring harness, increasing number of actuators and sensors, increasing data processing capabilities and required data bandwidth in the vehicle. Now increasing need of intelligent power distribution. So this is also one more important need. So you need to increase the need for intelligent power distribution. The power has to be distributed among the various ECUs so that the power consumption is optimum. Okay, so we have to make sure, or the automaker has to make sure, that ECUs are not eating too much of the power generated out of the limited battery power available in the vehicle. All right. Now, what are the various impacts of the E architecture? When it comes to system architecture, it is affecting the car wiring harness, it is affecting the organizational design of ECUs, it is also affecting the peripheral devices like actuators and sensors, and it is also affecting the cloud connection. Now coming to the software applications, it is software architecture, it is affecting the application services, it is also affecting the middleware and the operating system and basic software, also adaptive AutoSAR. Now game changers, time sensitive networking. So this time sensitive networking is a new form of automotive Ethernet, which is a definite game changer, or which is definitely looked at as a game changer as far as the system architecture impacts the software architecture. Now conversion into pure IP based end-to-end real-time communication enables intelligent power distribution and will be aligned with the data distribution in the new E architecture at the same time. So this time sensitive networking, TSN, is enabling conversion into pure IP based end-to-end real-time communication, which is enabling the intelligent power distribution. Okay, so these are the impacts of the E architecture. Now, when it comes to evolution of the E architecture, the first prevalent E architecture was distributed architecture, next is domain based architecture, and next is zonal based architecture. Now the most state of art is central vehicle architecture, which is currently in development. Now this central vehicle architecture is nothing but having a single computer for all the entire ECUs. Okay. Now what are the various trends? What are the various trends prevailing in the E architecture? Yesterday there were almost 30 to 100 ECUs, and today we have a domain ECU. Consolidation of ECUs into domain controllers reduces cost, weight, power consumption, leverages silicon and software innovations. And when it comes to tomorrow, redundant computing platform or zonal computing platform. This is service oriented architecture, direct memory, which has direct memory access. It also has parallel computing carrier, offer redundancy and safety, and open scalable platform for OEM system integration. Okay. Now when it comes to the future, the service oriented architecture, network access oriented, dynamic configuration, seamless redundancy, and blade upgradable concept. These are all the current trends. Now what is meant by domain ECU? Let me have a word about it. Now, domain ECU means there is a separate ECU for every functionality. For example, ADAS has a ECU, powertrain has a ECU, body control has a ECU, transmission has a ECU, infotainment has an ECU. Okay, so this is called domain ECUs, and this certainly is a evolvement of the or evolution from the modular, where randomly ECUs were randomly positioned across the car. So domain ECU is definitely upgraded version. It definitely has certain advantages when it comes to distribution ECU, but still there is further scope for development. Okay, I'll explain that in the coming videos. Thank you.